So I thought I'd give you a little bit more background on me. I am an educator. I'm a teaching faculty member, so I don't generally do a lot of research, but that's shifted over my career. So I kind of started in research and have shifted the whole way to the education side. But historically, I've been through Georgia Tech Strategic Energy Institute, the Applied Research Lab at Penn State, and now I've been with aerospace engineering for a while. Although I am a mechanical engineer and I teach for the energy and mineral engineering program, and all those things are tied together by renewable energy and my interest in energy systems. So I think the key here is that I'm not an expert on mines. I do teach wind and hydropower energy conversion. I've worked with students looking at the combination between wind and hydro and pumped storage. So I'm kind of coming here from the wind energy perspective, give you a little bit of background on kind of what's going on in the state and how the wind resources that are available in Pennsylvania do tend to complement sites that have historically had mining operations. So a little bit of background just on the wind project development process in general. If you're not familiar, so wind energy is interesting because, the sun is pretty predictable, right? You know it's going to rise and set. It might change a little bit with clouds each day. The wind is quite a bit more variable throughout the day and throughout the year and even from year to year. So you generally need to collect a good bit of wind data from a site. And you have to do it at the height, or at least above the buildings, above the trees, and there are ways to extrapolate it to higher heights. But if you're familiar with the boundary layer of the atmosphere, you tend to see an increase of wind speed with height. So height's an important factor. Also, the power in the wind is a function of the cube of the velocity. So there's a very big difference between a good wind site and a bad wind site. So again, very different from solar, where the sun is kind of ubiquitous; it's everywhere. I know there are solar experts who would argue with me about these things, but a really good solar site and a really bad solar site there might be like an 80% difference there. It's not as if you're doing some obvious things to stay out of the shade. With wind, the cubic effect really does impact things. So you have to have a really good handle on where the wind speeds are good. And I'll talk a little bit more about what are good wind speeds in a minute. But generally, that's early part of the process. Then you're working with landowners, you're getting permitting, securing engineering services, and getting all the approvals in process. So it takes a few years. But once you're actually building a project, it's just about maybe even a 6 to 9 month process. So this is all land-based. Offshore, a whole nother situation, at least double, maybe triple these timeframes. Obviously, working over water complicates everything, right? So just that's a little bit of a kind of overview of what goes into a project, and I'll talk a little bit more about the constituents of that in a bit too. So looking at Pennsylvania, really kind of the mid-Atlantic region here, this is a wind resource map. This is at 100 meters above the surface of the land, which is a pretty common height, and maybe even a little higher than that for like modern wind turbine wind farms. They're being developed so that the kind of center of rotation is around 100 to 120 meters, okay? So the dark blue is where we have windier locations throughout the state. And I'm going to be kind of storytelling through maps here. This is just the first of many, but this is the one where I probably have the darkest profile for the wind. But you can see it's really, we have it on wind on our ridges. Again, that increase in elevation, that's where we have our windier locations. Got a little bit more strong wind off of Lake Erie as well. Although it's not as strong as we see on the tops of our mountains. So that's generally where our wind projects are. But another thing that if you're looking for developing a wind project, you're going to want to know that there's transmission infrastructure nearby as well. So just overlaying that for reference and then bringing them together. And now you're actually looking at where there are large-scale wind projects in the state of Pennsylvania right now, and you can see they're all connected to that transmission grid. They're all in the darker blue area, and we're going to see soon that that actually complements really nicely where there's some abandoned mines as well, and some of them have been developed on those sites already. Another factor to consider with wind energy is that there are absolutely no projects on state land in this state. Zero. And it's a policy thing, but it's also, land rights, air rights, that they don't necessarily have the right to develop projects. So it's something to just also kind of be aware of. And that happens to also overlap quite a bit with where we have available wind in this state. So you can see on here, we've got DCNR sites in green, and the red and the blue are locations that are considered of high wind resource that are also on state land in Pennsylvania. So we aren't developing projects specifically in those spots. So if there is land that is not owned by the state, but adjacent, and that's largely where a lot of the projects to date have been built, are really adjacent to these locations, then there's a lot of opportunity near those locations. Okay, so back to kind of the story map. This is, I know I had, yeah. So these sites down here that you're seeing that with the star, those are locations that wind projects that have been developed that have touted that these are being developed on abandoned mine sites, so brownfield sites, and that was, I'm sure, part of how they got the community engaged in these projects, and it made sense in particular. There may be more, those were just from me kind of looking a little bit, but there is also, oh, okay, and this is just kind of overlaying all these maps again. So this is where the state forests are, and where the wind turbines are, and the wind, and the transmission. And this is where Pennsylvania state game land are located. And I don't know, we've been told, if there was kind of a swap of land possible, that, it's not that they wouldn't consider a wind project, but to date, there have not been any developed on state land. Okay, so now overlaying this wind map, the transmission map with abandoned mine land inventory, you can see, again, there is a nice complement in several parts of, I've got a pointer here, right? So certainly in the Northeast, there's a lot of overlap in this area, and as well in the Southwest. The areas kind of middle part of the state to the west, not so much, because we just don't have as much high mountains over there. Am I going the right way? I think this is just bringing all of that together. So so a lot of the places where we have state land, there might be some abandoned mine land actually nearby as well, where we have these resources. So there can be very much a nice match there. So, we talk a lot about utility scale wind projects. This is things that have the projects I pointed out, though, all of these are 100 megawatt plus scale, mostly projects in the state that are highlighted on this map. And that's largely what I'm going to talk about, but I want to at least mention, the possibility of doing distributed wind projects. So if you have smaller turbines or maybe a single larger turbine, that can be used for on-site applications. If you need a remote, if particularly you're not near the grid, but you need power, maybe this is more likely for water purification processes rather than for power generation, obviously, and sending it to the grid. There's probably lots of opportunities for that, and a less rigorous process to go through than what I described before. You want to know your wind resource, but you're probably able to get away with taking maybe 1 year of data rather than 2 or 3 years of data, and it's all scales kind of with the size of the project and the amount of investment and the amount of risk that might be acceptable for a project. So another large-scale project that's actually under development right now, Rogue Wind, 114 megawatts. You can see on the map here where it is with the star right here. And I'm going to point out that kind of the average wind speed, I don't know exactly where the project is, but just looking at these abandoned mine sites in the area, 7.9 meter per second annual average wind speed. So I would say anything between 7.5, 8 meters per second at 100 meter elevation is a pretty strong wind resource. Above 8 is the higher the better for sure. But I'm going to show you some examples from around the state that we definitely have this sort of resource on these lands. And if you go up to higher elevations, so taller turbines, you can extract even more power as well. Okay, so just some additional considerations for wind projects. I mean, generally prior mining activities means that there's roads, there is transmission infrastructure in place, which does help reduce project costs. I'm sure that's been a benefit to those projects that have already pursued those sites. Still need to do a full environmental and societal impact analysis, and I'll touch on some of these things, but as I talked about, wind resource assessment's important. You want to collect a couple of years of data, and then I'll kind of compare that data with historical data to see if those are representative years or if you need to extrapolate further. Interconnection study, can the grid at the location take that power and send it where it's needed? Some preliminary environmental studies to understand what the pre-construction impact is and if there are special species of concern in the area. Big thing is land agreements and working with the landowners. So generally when projects aren't built on land owned by the companies, you're leasing the land from a landowner for a period of time, 20 to 30 years, depending on the length of the project. Who's going to purchase the power? Usually they do power purchase agreements with large wind projects, maybe a large entity, or they could be sold in the energy market as well. Selecting the turbine technology, working with the company to match that with the wind resource available and the type of turbine that you want at the site, and of course then all the logistics and construction and commissioning. But again, a much smaller project could be completed in a shorter time frame with a little bit less depth of all of these things. In Pennsylvania, we're a commonwealth. Each locality can handle projects differently. We do have a model wind ordinance in Pennsylvania, and some individual localities have townships, boroughs have their own version of that. Some have nothing. That's one of the complications with working in the state, but there's usually a differentiation between a small project and a large project in terms of what would be required from a permitting perspective. Some of the stakeholders involved, you've got the developers. Just throughout, this is a slide I actually used for just education purposes, so I didn't change a thing. But there are companies out there that are putting together the whole plan for the project and bringing all the relevant people together, getting the land agreements in place, starting the process of the interconnection ties. And then there could be the landowners. There could be actually an owner-operator after the fact that's different than the developer, the people who are purchasing the power. You usually have some companies that are very highly specialized in meteorology to do the detailed wind resource assessment or be that third party. Maybe they do that in-house, but then you have a third party person or group analyzing your data as well. And of course, wildlife and environmental specialists who are involved, usually, that's sometimes in-house, but usually contracted out. Again, equipment manufacturers, permitting, financiers. Big part of wind projects, large wind projects, is there's usually some equity investor, and that may all change in the future, but with the tax incentive structure that they kind of have at present, I say that with a question mark, that is often a way to help make a project work is having somebody with a tax appetite who's putting money in, but then they get it out in the early years of the project through the tax equity or incentives. And again, the owner-operator might be transferred to another company after it starts operating. And there are other stakeholders, so nearby landowners. They might have been approached about the project, and maybe they don't want a turbine there, or maybe they aren't chosen for a site, but they are stakeholders. And so having those people engaged, and I think talking with people early on about projects also is definitely highly recommended for probably all of these systems. Okay, and then getting into some of the common societal concerns, because these are, a lot of people hear about how loud wind turbines are. They're so noisy. They're generally, I don't know, I usually look for where the projector is and try and identify the noise coming from it. It's, it's a little higher up in this room than some of the classrooms that I teach in, but I mean, it's usually about the sound level of what's coming out of that projector, which if you're a little closer to it, it's probably a little bit more annoying. But yeah, it's dissipating as you're getting further away. And that's the same thing with the wind turbine. And usually that's dictated by your local ordinances. How loud is it allowed to be? And so that's how turbines are designed. So generally at about 45 to, they're usually within the range about 45 to 50 decibels at something on the order of 1,000 feet. They're, what do I have there? Distance of 1,000 to 2,000 feet. So obviously there's wiggle room, but they're not noisy from a like industrial noise perspective, but I liken it more to a ticking clock. If I'm in a quiet room with a ticking clock, kind of is annoying to me, yeah. You could also relate it to the sound of waves crashing on the beach. But there's enough of an irregularity to that noise that you don't hear people talking about beach rage. You know, you hear people talking about, you know, wind turbine syndrome and this sound, but it's not that it's loud, it's just that it's a regular noise. So I can imagine if I moved to the country in a site that I enjoy the sound of nature at night, and then all of a sudden you're putting a wind turbine in that environment, that would piss me off, yeah. So that's something to also consider with wind energy. It is not harmful, but it could be just something you didn't want, right? So, and when it is windy, you probably wouldn't hear it because the sound of the wind would be louder than the turbines. So it's more on the quiet, lower wind speed nights that you hear wind. Or the wind turbines. Other things that wind turbines are generally people talk about, and this has a lot to do with really early projects in the 80s out in California, and really the turbine technology has changed quite a bit since then, but generally wind turbines aren't killing tons of birds. Cats are the #1 killer of birds. If you want to make an impact, keep your cat indoors or put a bell on it. That's probably the #1 thing I can say. But they're also just running into buildings. And in that sense, any man-made object a bird could run into if there was low visibility, if there's lights on at night and they're attracted to it. So that does happen. Not to say that it's not some impact, and it is something they have to consider. You don't put a wind farm in a migratory bird route. Now, they learned that lesson. That's something that would be avoided. So is it possible for them to run into a blade? Yes, it's possible, but they generally spin much more slowly than those early machines. The birds tend to see them and go around them. They have studies around that. It's more typical for a whole flock of birds to experience a collision event because of an alignment of being the migration season, low visibility, and artificial lighting. But this is not a specific thing to wind. This is buildings, this is cliffs. This is not even just man-made stuff. Birds just can run into things in low visibility. Bats, definitely a more special species in that if a bat is killed, it takes longer for them to repopulate. They only have generally one young at a time. And I think so as a part of wind project development, they're usually looking at what will be the impact on bats. You know, if there are bat hibernacula in the area, what is your mitigation approach to this? And actually, Castleman Wind Farm in Somerset is one of the early projects that did an operational study and found that increasing the cut-in wind speed, so that means not turning the turbine on until the wind speeds are a little bit higher, can have a huge reduction in bat mortality. And this is very much in like the fall migration, I think August to October timeframe, that this is an issue, at least at some locations. So having a plan like that, like we're going to increase the cut-in wind speed of our wind turbines in this time frame each year to minimize the impact on bats is something that is common to expect from a wind project today. Also looking at other ways to mitigate that impact. Industry's still studying this as well. Watershed impact. So I've heard this from one of the tour guides that I used to go on, take students on tours with, but he would liken the wind project to basically a series of high-rise buildings, each at the end of a cul-de-sac. And, maybe not the, all the luxury amenities that you're having in those locations, but you have high power and you have roads, infrastructure. And, we know how to build roads so that you're not impacting watersheds. And you just need to apply that and maintain it on wind project sites. So conforming to regulations along those lines. So proper maintenance is important. Forest fragmentation also an issue, but it's only less than an acre per turbine that's really needed to be cleared, maybe even a little bit less than that. It depends on the construction. Okay, so now I'm going to highlight a few locations that, just looking at ArcGIS, pulling in a few maps, and kind of working my way from the northeast side down to southwest, pulled a few sites just for reference. So this is near Forest City, and it's a little bit hard to see, but I have this area highlighted here, and I was looking at the average wind speed for this location, again, at 100 meters, 7.72 meters per second. If I go down just a little bit further, kind of the same picture here, but now I'm looking down here, this is 7.3 meters per second, near the old Forge borehole, I believe. Going down a little further towards Hazleton, 7.63 meters per second, average wind speed in that area. South of Hazleton, 7.83, and I just picked a random one. I mean, you could click all over the place and you'd probably be seeing similar values. So you can actually see wind turbines. You might have seen them on the other ones, but these are all installed industrial scale wind turbines nearby. And you can see also the transmission lines going to them, but just another site here, 8.65 meters per second. So this particular location, extremely windy. I was looking up, kind of curious about this Shen Pen abandoned pit, and 7.75 meters per second in that area. Near Centralia, 7.96 in this big block. Certainly from one location to another, it's a little bit of variability, but there's a lot of really good wind out there. Anything approaching 8 meters per second, definitely something worth investigating. And Sandy Ridge, where is the blue mark on here? My eyes are failing me, but I guess I'm using no, I can't see which one is highlighted, but another idea. And then way down in the southwest, northeast of Somerset, another site. It is right in here, 8.2 meters per second. So just a little bit of a walking through, in looking at the wind resource. Haven't dug much further than that. If you want these maps from me, just let me know. I could probably share through ArcGIS. And